Hello guys, myself Swapnil Sir and welcome to yet another video on our channel. So already we have started lecture series based on different topic from SPI previous year question paper. So in my today's video, I'm going to explain to you all one of the very much important topic for your SPI exam, which is exactly mensuration. That topic carries near about 10 to 15 questions in your SPI exam. That means see that how that topic having weightage in your SPI exam. Now see that if I'm going to start this topic, first of all we are going to learn some of the basic concept from mensuration chapter, and at the end we go for some previous year question along with the possible important question based on the SPI exam. Okay. So already I have uploaded plenty of the videos on my channel. So if you do interested to see these, do check in my playlist. You will get the plenty of the videos. And along with that, if you found anything difficult, anything confusing, if you want to learn something new, let me know in my comment section. I will come up with the similar videos. Okay, so as I'm talking about the SPI exam, already we have started some mock test based on the SPI exam. So you can get all these mock tests in our Adhyan application. Okay, so you do check these ones there. Okay, so as the SPI exam is coming, so I feel that we have to go for detailed understanding about the mensuration chapter. Okay. In our mensuration chapter, we know that there are near about 10 to 15 questions are there that comes for your SPI exam. These questions based only on the part of a solid figure and plane figure. Okay, actually mensuration part is divided by into two part. Mensuration it is divided into the two part. Actually, one is the plane figure, another one is a solid figure. Now, plane figure which divided here as the perimeter, area, circumference, this kind of a concept comes under the plane figure. Okay, and when we go for the solid figure gives us like a cone, cuboid, cylinder, after that sphere, hemisphere. This type of the figures comes under solid figures. Okay, and the question based on this plane and solid figure, it's near about 10 to 15 questions. Okay, and just we have to understand what is the circumference, what is the area, what is this condition for the plane figure, and about the solid figure we have to understand only for like volume, like surface area, lateral surface area, curved surface area, total surface area. So only these topics are very much important for your SPI exam. Total 15 number of questions based on these topics only. Okay, so without further ado, let's dive into our today's lecture. First of all, I'm going to explain to you all some of the basic concept along with some formulas, and simultaneously I will explain and I will use some of the tricks that you can remember these formulas. Okay, so let's start our today's lecture. So here you can see this one is our next lecture based on the mensuration. So let's start our today's lecture. Yes, so in our today's lecture I will explain to you all concept of mensuration. So here in our mensuration we can see the mensuration is generally divided into the two parts. Okay, so let me write these two parts here. First part it goes for plane figure. First part it goes for the plane figure, and second it goes for the solid figure. Okay, and now generally the difference between plane figure and solid figure it is here, as we can plot a plane figure in only two-dimensional space, like a x-axis and y-axis. We can plot a plane figure. Okay, now let me plot the plane figure here with the x-axis and y-axis. Now we can see generally we learn this concept in your coordinate chapter in my previous lecture. Okay, now see that we have x-axis, y-axis. Okay, so if we plot some coordinate here in x and y-axis, we get some sort of a plane figure like a triangle, like a circle. These type of the plane figures are coming here. Okay, so in our plane figure we have to worry about only with the area of a triangle. Okay, area of a triangle, then the area of a circle, after that circumference of circle. Okay, after that perimeter we have to think about it. Okay, all these concepts are very much important here for the plane figure. Okay, so that's it for the plane figure question. Based on this plane figure, you will get it in SPI exam. Okay, so make sure that these three condition has to be perfect for you all. Okay, now let's move for the next condition. It is for a solid figure. Okay, so mensuration's next part we have here as a solid figure. As I explained here, solid figure, we need a three-dimensional space to plot this one. Okay, now see that for the three-dimensional space we can plot like x-axis, y-axis and z-axis. You can take any figure here, like if I consider cone here. So see that this one is our cone in our three-dimensional. That means a solid figure means we can see its three sides. Okay, when three sides of any closed figure it is visible to us, then we say that it is a solid figure. Okay, now how many shapes are coming in under solid figure? Now see that there are so many shapes that comes under solid figure, but as per the SPI question paper we have to focus on some sort of specific part. Okay, like first we consider here cylinder. First we consider here cylinder. Second we go for the cone. Okay, third we go for the sphere. Fourth we go for the hemisphere. Okay, after that we go for the cube, and after we have cuboid. Okay, these all are our solid figures. Majorly the question based on these topics I have seen in our SPI question paper. Okay, now see that it is not that difficult. Easily you can find out their answers using these closed figures. Okay, like a cylinder, if you wanted to study about a cylinder, you need to know what is the volume of a cylinder, what is the surface area of a cylinder, what is the curved surface area, what is the lateral surface area, and what is the total surface area for cylinder. Okay, all these concepts you need to know, so you can attempt very easily these questions. Okay, now for example, if you have given a radius for a cylinder or a height for a cylinder, that means you can easily find it out what is the volume for a cylinder. Okay, so for that you need to know what is the formula for volume of a cylinder, like a pi r square h. These things you all have to be familiar. Okay, so in our today's lecture I will explain to you all some of the short trick that you can remember all these formulas. Okay, if you want some extra lecture based on this solid figure, let me know in comment section. I will come up with some tricks and short point that you can remember this formula for your lifelong. Okay, so let's start our plane figure and solid figure. As we know that area of a triangle, which is 1/2 into base into height, nothing it is difficult. Okay, then you can see for the centroid for the triangle. Centroid for the triangle means add 3 of these vertices and divide by 3, you will get the centroid. Okay, so in our triangle we can go for the right angle triangle, obtuse angle triangle and acute angle triangle. Okay, so when you have regular triangle we can take 1/2 into base into height. Okay, as their area of a triangle. Okay, when you have equilateral triangle, that means there's all sides equal, angles are there equal, or isosceles triangle, 2 sides are equal, that time we have different area than our regular triangle. Okay, yes, and if we take a equilateral triangle, we know that √3/4 into side square, it is the area of this triangle. Okay, all these concept you need to know. Okay, about the triangle, that's it important here. About the circle, we need to know area of a circle, which is a pi r square. Circumference of a circle is a pi r square. Okay, this concept you need to know here. What is the actual area for our circle? Area means the part inside here in our circle. Okay, we consider this one is the area for circle. Okay, and the circumference of a circle means only the boundary line. Okay, now see, we can see here only we have boundary line. That boundary line we consider it as the circumference for our circle. Okay, so that's it only here for the plane figure. We don't have only triangle and circle in our plane figure, as we have quadrilaterals, rhombus, like a parallelogram, all these type of the figures comes under plane figure. Okay, that means you need to know the equation for circle, which is x square plus y square, which is equal to r square. Okay, when center is a 0 0, when center is a hk, we have to understand x minus h square plus y minus square is equal to r square, which is the equation of a circle. Okay, these concepts are very much important in your plane figure part. Okay, so mensuration generally gives for plane figure like a 4 to 5 questions. Okay, and for the solid figure it goes to 6 to 7 question, more than 6 to 7 question. Okay, so you all have to understand this importance for these two part. Okay, I hope you all have understood for everything for the plane figure. Now let me explain for the solid figure. Okay, these formulas are quite much easier. As you solve more and more a question, you can understand it very easily. Okay, now let me move for a solid figure. Okay, what actually mean by solid figure? Okay, I will explain here the solid figure with some of the example and how can we remember their formulas. Okay, that's it, our challenging part here. Okay, now let me explain with the solid figure. Solid figure. Okay, now what about for solid figure? Let me consider one solid figure as a cylinder. Okay, now let me explain with the cylinder. Okay, I know that you all have seen cylinder, everyone. Okay, but let me show you one solid figure for cylinder. Okay, now as we know that, see that we have this type of the figures, like we consider it as the solid. Okay, so solid figure, which is actually our cylinder. Okay, this one is actually cylinder. Now see that the around part of that cylinder, now see that this is a rounded part for our cylinder. We consider it is the curved part. Okay, curved part means it is a curved shape around here. We consider this one is the curved shape or lateral surface area. Okay, what we have here, curved surface area or lateral surface area for this cylinder. Okay, now this one is curved and lateral surface area. When we go from the upper part and when we go for our downside part, okay, that we cannot say upside part and downside part are curved because we have some plane part here. Okay, now we can see this one is our circle here. Okay, this one is our complete circle, this one is our complete circle. Okay, so and what about for volume? Volume means the inside part. Okay, what we can pour inside in our cylinder. Okay, the inside part of a cylinder we consider as the volume for a cylinder. Okay, now let me explain. When we have cylinder, okay, when we have cylinder, how much water we can pour inside that cylinder? Okay, how much water we can pour inside that cylinder, we call it as the volume. Volume for our cylinder. Okay, that's it for volume of our cylinder. And the upside part and downside part and curved part we consider it as the total surface area. Okay, surface area generally divided by lateral or curved surface area plus remaining part of the surface area. Okay, now we can see that this one upper side is a circle. Okay, downside part also we have circle. And here we can see we have curved surface area or lateral. Okay, curved surface area or lateral surface area. Okay, what we in mathematics we have to fill the words. Curved means it is having curved shape. Okay, lateral curved means it is having curved or lateral shape. Okay, plane means it is completely plane or flat surface. Okay, volume means what we have inside our closed figure. Okay, that we have to fill this meaning of these words. Okay, then it is easier to find out the answers here. Okay, yes, yes. Now let's go for the next part. I explain here what is the volume. Volume inside part here in our cylinder. Okay, now what is the volume for our cylinder? How can we find the volume of our cylinder? Now most of you are feeling that it is really difficult and confusing, but it's not like that. If you come to understand what is the actual area and circumference for circle, that easily you can deal these figures. Three-dimensional figure are not that difficult, but you need to have an basic concept perfect. Okay. Now let me explain with the circle. We know that the area of a circle is a, what we have, area of circle. What we have, area of a circle, which is the pi r square. Okay. Pi is a 22/7 or 3.14. Okay. Something that you can take the value. Okay. Pi, it is a constant here, and radia we have here is the radius for our circle. Okay. This is the distance from here to here. Now we can see cylinder, it is a special type of the circle. Okay. But a circle we consider into the two-dimensional figure. Actually it do not have any height or anything. It is just a plain figure. But when we come to the cylinder, now consider I do have coin. I do have coin here. Okay. If I placed coin on coin, I place 20 coin on coin. Okay. So I have these many coins here with the 20 amount of coin. Okay. Now we can see that we have one more factor extra here in these coins, which is the, now see that this one is the first coin. After that I place second coin here, third coin here. That 20 amount of a coin I placed here. Okay. Now we can see here this many amount of a coin can make cylinder. Okay. These many amount of a coin can make the cylinder. Okay. Now see that in a 2D figure we have area as the part of our circle. Okay. But in a 3D figure we convert that area into the volume. Okay. What we convert? Area we convert into the volume. Now see that this one is the area. In 3D figure we consider it as the volume. Okay. This one is the volume. Okay. Now see that what extra factor we are getting here in the volume. Okay. When we have area, we don't have any kind of a height. It is a plain figure. Plain figure do not have any height. Okay. But when we go for a solid figure, we get some extra sort of a height or something extra things here. Now which is the volume. Okay. What is the volume for cylinder? Which is the area of a circle remain as it is, but we have extra factor which is the height. Okay. That means pi r square h is the volume for our cylinder. Now see that how easy it is. Nothing we have difficult. Okay. Everything it is easier. So if you come to understand this concept, it is easier to find out the remaining one. For cone, if you are going to find out the cone, which is a 1/3 pi r square h is the volume for our cone. Okay. So if you are going for cone to sphere, okay, if you going from cone to sphere, we get the 4/3 pi r square h is the volume. If you go from sphere to hemisphere, you get the 2/3 pi r square as the volume. Okay. But when we come to the part of a sphere or hemisphere, we don't have height. We have radii. Okay, height and radius are equal in the case of hemisphere. Okay, then we write 1/3 pi r cube, h as the only radius. Okay, so we write in the case of a sphere, which is a 4/3 pi r cube as the volume. Okay, and when we go for the hemisphere, when we cut sphere into the two part, we get the hemisphere. Okay, so then we get as the 2/3 pi r cube as the volume for hemisphere. Okay. The remaining for curved surface area, total surface area and lateral surface area, I'm going to explain to you all now here. Okay. Now we can see curved surface area, lateral surface area, we can write this one here. Okay. Now see that this one is only the curved surface area, rounded part. Okay. Only the rounded part, it has the curved or lateral surface area. Okay. Yes. Now we know that curved surface area or lateral surface area, okay, curved surface area or lateral surface area for our cylinder. Okay. Now see that this one is our curved surface and lateral surface area for our cylinder. Okay. Now what is the curved surface area and lateral surface area? In the sense of a circle, we have circumference. in the sense of a circle, we have circumference in a plane figure. Okay, but when we convert into the 3D figure or solid figure, it gives us curved surface or lateral surface area. Okay, that means we know that the circumference of a circle, okay, which is a 2 pi r. Okay, and in same condition here for the solid figure here, for total surface area, circumference can converted into the total surface area. Okay, that is the major difference here that you all have to understand. Okay, so I'm expecting that you all have understood what is the curved surface area, total surface area, now lateral surface area. Okay, now what about for total surface area? Total surface area means the area of a top plus area of a bottom plus curved surface area and lateral surface area. When we add all these surface area, we get the total surface area for the cylinder. Okay, I am expecting that you all have understood all these concepts. Okay, so if you wanted to see this concept in detail, let me know in my comment section. I will come up with the separate video based on this mensuration part. Okay, now see that everyone, I do have a lot more tricks, a lot more things to tell you all, because I need some extra lecture to explain all these things. It's not possible everything in our today's lecture, but if you are interested, let me know in my comment section. Okay, I will come up with the similar video in our channel. Okay, okay, let's move for some of the example. Okay, okay, I will explain some another figure too. Okay, let me explain first. Curved surface area, lateral surface area and volume. I will explain these formulas while we are solving the example. Okay, so as earlier we learned there, this one is our cylinder. Okay, we can see this one is our cylinder. This one is our cylinder. Okay, after that let me plot cone here. As you all can see, you all have wear already a cap of a birthday cap. Okay, birthday cap, it's look like a cone shape. Okay, or you may have taken like a cone, like ice cream cone. It's similar like shape. Okay, so this one is a height for our cone. This one is our cone. Okay, now let me explain sphere. What is mean by actual sphere? Okay, I know that you all are playing football, volleyball. This type of the figure we consider the sphere. Okay, because it is completely rounded, it's like a spherical shape. Okay, then we consider it as the sphere. Okay, let me draw the sphere here first. Okay, this one is our sphere. So we can see we have a sphere here. Okay, which is the center. Okay, which is some sort of a spherical figure. Okay, which is having solid shape like a 3D figure. Okay, so we can call it as the sphere. This one is our sphere. Okay, after that hemisphere. What actually meaning of hemisphere? When we cut complete sphere into the two part. Okay, so we get the two different part. Okay, when we cut complete sphere into the two part, we get the two different part of sphere. So we consider one of the part as a hemisphere. Okay, now what we have hemisphere? Now see that cut this part into the equal part from upper and lower side. So, but make sure that both part has to be equal. Okay, you cannot cut from here or some another place. When we want hemisphere, we have to cut sphere into the two equal part. Okay, two equal part. Now see that this one is our hemisphere. Okay, so let me draw it again. So we can consider this one as our hemisphere. Okay, so as you all can see, my drawing is not that good, but I can plot here hemisphere. Okay, now see that this one is our 3D shape. We consider it as the hemisphere. Okay, when we cut sphere into the two equal part, we get the hemisphere. We get the hemisphere. Okay, first it start from a cylinder. It's for the cone, it is for sphere, it is the hemisphere. Okay, after that cube and cuboid. Okay, Now what is mean by cube? The all sides of the cube or edge of a cube, like a length, breadth, height, all these edges of our cube are equal. Okay, when all these edges are equal, we consider this one as the cube. Okay, now let me plot the cube here. Now we can see this one is our cube. Consider all these sides are equal, that means length, breadth and height all are equal here. Okay, so we call it as the cube. Okay, that means length. Now see that we have height here, it is a length here and it's a breadth here. Okay, but in the case of a cube, we consider length equal to breadth equal to height. Okay, that means all the sides of a cube are always equal. That means we consider the volume of a cube, which is the length into breadth into height. But the all edges, as we have same here, we call it as the volume of a cube as the a cube only. Okay, volume of a cube we consider it as the only a cube. Okay, that means length multiplied by breadth multiplied by height. But length which is equal to a, breadth which is equal to a, and height which is equal to a, we call it as the complete volume. Okay, that means a cube, it is the volume of a cube. Okay, now what about for the surface area, curved surface area and total surface area? Now curved surface area, as we have 4 sides, then we consider curved surface area 2 times length into breadth. Okay, that means 4 times a square. Okay, now see that how many surface we have here only at the curved surface. Okay, we have to look for our curved surface only. Now see that, consider this one is our sphere. Okay, this one is first, second, third and fourth. All we have curved surface here. Okay, area of a top and area of a bottom we don't have to consider here. Okay, this one is not the curved surface. Only curved surface, first part, second part, third part and fourth part. Okay, we have 4 part of the curved surface area. So that means 4 times a square is the curved surface area for our cube. Okay, now total surface area, that means area of a top, area of a bottom, this part, this one also, front part and back part. Okay, front part and backward part. Total amount of how many sides we have here? 6 times a square. Okay, so this one is our curved surface area for our cube, and total surface area for cube 6 times a square we have here. Okay, so that's it for the cube. Now what about for cuboid? Okay, let me draw cuboid here. Actually, what is the difference between cube and cuboid? In the cube, we have length, breadth and height all are equal. But in the cuboid, length it is not equal to breadth and breadth not equal to height. Okay, all these sides are different. Okay, now we can consider this like shape. Okay, let me plot here first of all cuboid. Okay, yes. Now we can see that this one is a length, height and this one is a breadth. Okay, length not equal to breadth not equal to height. Okay, if these 3 sides are not equal, that means these 3 edges are not equal in our cuboid. Okay, what is this cuboid figure? This is the cuboid. Okay, if length, breadth and height, if these 3 sides are not equal, then we write volume of a cuboid length into breadth into height. Okay, length into breadth into height. Now what about for curved surface area and total surface area? Okay, curved surface area means that area which from around of this cuboid. Total surface area means area of a top, area of a bottom and all we have curved or lateral surface that come under cuboid. Okay, now you all have to be very much careful about this type of the figures. Okay, learn all of these concepts properly: cylinder, cone, sphere, hemisphere, cube and a cuboid. Okay, as I have given a little overview for this concept, you all have to prepare, because near about 7 to 8 question you can get it from your question paper. Okay, so as I'm expecting you will get 7 to 8 question based on these topics. So do prepare these topics properly, and if you want more detailed video about this mensuration part, let me know in my comment section. I will come up with a separate video. Okay, now let's move for some of the question. Okay, So different formulas I already explained here about the volume. Okay, about volume I explained here. Second, I explained here total surface area. Total surface area. Third, I explained here lateral surface area. Oblique curved surface. Lateral surface area, curved surface area. That's it here. Total surface means we have to add all the surface here. About the solid figure, okay, this one is only for the solid figure. Okay, you all have to understand the meaning for solid figure. I hope you all have understood everything about solid figure. Now about the plane figure, I know that you all are familiar with the plane figure, like area, circumference, perimeter, the diagonal, okay, anti-diagonal. This kind of the concept comes under plane figure. Okay, mostly you have to face these concepts. Now I am expecting you all have understood everything here. Okay, yes. So let's get start our today's examples. Okay, so we'll start some of the example based on our topic. Okay, that I have explained here. Okay, let's start our today's lecture with some of the previous year questions from SPI. Some of the questions, they are not from the SPI previous year question, but as I have seen the question from your SPI question paper, this similar type of the question you will get it there. Okay, so I made this question by myself, that to make you feel that this type of the calculations are coming in your SPI exam. Okay, so I made these questions, some of question I made myself, because this similar type of the question I found in our SPI question paper. Okay, so let's start our first question. Our first question is says that which one of the following is a ones of a rhombus. Okay, so question, it is quite bit confusing to understand, but not the difficult. Okay, once you understand actual meaning, okay, it's not that difficult to solve the question. Okay, what we have question, which one of the following is a ones of a rhombus. Okay, we have given rhombus here. Okay, now let me plot the rhombus, how it look like. Okay, this one we have rhombus here. So these are the diagonal, this one is the anti-diagonal. Okay, okay, so consider A, B, C, D. Okay, first of all you all have to visualize what we have given in our question. Once you come to understand what we have given, then further part it's not that difficult. Okay, yes, we have given rhombus, which is a ABCD rhombus we have here. I given name, as we have two diagonal, give them a name D2 and a D1. Okay, we have diagonal D1 and D2. Okay, yes, because in our option we have given diagonal. Okay, now we can see that here our first option, it says that product of diagonal. Okay, product of diagonal. Next we can see here one half product of its diagonal. Okay, third option, it says that 2 times product of its diagonal, and fourth option, it says that 1/2 sum of its diagonal. Okay, now as we can see, it gives a sense like a area of a rhombus. Okay, what we have area of a rhombus? Area of rhombus. Okay, it gives a little sense like a area of a rhombus. Okay, and what we have area of a rhombus, we write area of a rhombus 1/2 multiplied by first diagonal into second diagonal. Okay, 1/2 multiplied by first diagonal into second diagonal. Okay, this one is our area of a rhombus. Now you all have to understand, think logically. If we have given 1/2 into product of its diagonal, that means it is the area of a rhombus. Okay, most of the case questions are quite confusing in your SPI question paper, but meaning for that is not difficult. Okay, If you have good concept, you can answer this question in a quiet second. Okay. Now see that area of a rhombus, we write it as the 1/2 multiplication of a diagonal. Okay. Now see that product of diagonal never possible because 1/2 it is also there. So first option discarded. Second says that 2 times product of its diagonal. Okay. Here it is a 2 times. It is a 1/2 time product of its diagonal. Okay. Yes. So second, third option is discarded here. Okay. Now fourth option, it says that 1/2 into sum of its diagonal, but it is not a sum. In actual we have multiplication. Okay. So fourth option is discarded. Now we have second option, 1/2 into product of its diagonal, which is the correct option here. Okay. What is the area of a rhombus? Which is a 1/2 into first diagonal multiplied by second diagonal. Okay. So I'm expecting that you all have understood this question. Nothing we have difficult here. Let's move for the next question. Okay. Okay. In our next question, we have given age of a cube is 1 centimeter. Then which one of the following is its volume? Okay. Now see that we have to deal with the volume, concept of a volume. Okay. Now let me plot first of all a cube here. Okay. Already I explained here how the cube and a cuboid look like. Cube and cuboid both are having different meaning. Okay. So we have given cube. Let me plot the cube first. Okay. This one is our first part, and second one we can draw it here. Now see that this one is our cube here. Okay. This one is the length, breadth and height. In the cube, okay, in the case of a cube, we write length equal to breadth equal to height. Okay. That means volume of cube. What is the volume of a cube? Length into breadth into height, and all are equal, considered equal to A. That means A multiplied by A multiplied by A, we write A cube. Okay. That means we have in our cube volume of a cube is a age cube or A cube. Okay. A cube means I consider here A as a age. Okay. A as the age here. Okay. Yes. Now we can see we have volume of a cube which is a cube. Now we have given age of a cube is 1 centimeter. Okay. Age of 1 centimeter. Okay. We have age of a cube. It is a 1 centimeter. Now substitute this value in the place of a cube. Okay. So we write volume of cube. Okay. We write volume of a cube which is a cube means 1 cube which is equal to 1. Now which is equal to 1. But what about for unit? Unit for volume, unit for surface area, or unit for two-dimensional figure. When you have a plain figure, like that time you have to consider centimeter square. When you have given a solid figure, always remember that solid figure contain cubic centimeter as the unit. Okay. That means we write 1 centimeter cube. Okay. 1 centimeter cube we write. And already we have given in the form of meter. Then we write 1 meter cube here. Okay. So which one is the correct option? 1 meter cube, which is our correct option in this answer. Okay. In this question. Now see that similar type of the question you can see in your question paper. Okay. You can find these questions from Pyqs. Okay. And in upcoming question paper, you will get the similar question. Okay. I'm expecting you all have understood. Let's move for next question. Okay. In our next question, we have given the parallel sides of a parallelogram 2 centimeters. Apart from its sum is the 10 centimeter. Then its area. Okay. So you all have to understand what is the area for parallelogram. Okay. Let me plot the parallelogram first. Okay. Okay. Parallelogram, let me plot here. We have parallelogram. This one is our parallelogram. Okay. Consider we have this parallelogram. Okay. Give them a name A. A, B, C and D. This one is our parallelogram. Okay. Yes. So which is having diagonal, 2 diagonal. Okay. D1 and D2. Okay. Now we have given parallel sides of the parallelogram are 2 centimeter apart from their sum. That means AB and DC. Okay, AB parallel to DC. Okay, AB line segment AB, which is a parallel to the line segment DC. Similarly, we write line segment AD parallel to the line segment BC. Okay, so these two are the line segments which are parallel to each other. Okay, yes. Okay, and we know that these are the parallel, and the parallel sides of the parallelogram are 2 centimeter. That means parallel side is given as the measurement 2 centimeter here. Okay, yes. Now what we do here, we have to find out the their area. Okay, now parallel sides of the parallelogram and their sum, that means AB plus CD. Okay, AB plus CD or DC, we write AB plus DC, which is equal to 10 centimeter. Okay, what we have given apart from their sum is a 10 centimeter. That means this plus this we write 10 centimeter. Okay, their addition of a parallel side we write it as the 10 centimeter. Okay, if a line segment AB, which is the parallel to line segment DC, so let's consider AB line segment equal to line segment DC. Okay, then we write AB which is equal to DC. What I have done here, I consider line segment AB which is equal to DC. Okay, if these two line segments are equal, then we write AB which is equal to DC, then AB plus DC is a 10 centimeter. That means we write AB plus AB. Okay, because DC having value AB here. Okay, because AB and DC both are the equal sides, so I can replace DC as AB here, which is equal to 10 centimeter. So AB plus AB, we write 2 times AB which is equal to 10 centimeter, and we write AB which is equal to 10 divided by 2, which is a 5 centimeter. Okay, as we have the 2-dimensional figure, so we write centimeter square. Okay, yes. Now see that we want the measurement for their side, which is a 10 centimeter square, which is given in our option number B here. Okay, now see that how easy type of the questions are this. You just have to understand the meaning for question. I hope you all have understood. Let's move for the next question. Okay, the age of a cube is a 1 centimeter, then which one of the following is a total surface area? Okay, so total surface area for our cube you have to understand. Okay, total surface area and curved surface area. What we have for cube? Let me plot the cube first. Okay, this one is our cube. Okay, then curved surface area, total surface area and volume. Okay, curved surface area, that means the part around our cube here. So we write 4 times A square. Total surface area, that means area of a top, area of a bottom, and the around surface, we write 6 times A square. And volume, we write A cube. Okay, length into breadth into height, but all these are equal in the case of a cube. Okay, so volume it is A cube, total surface area 6A square, curved surface area 4 times A square we have here. Okay, yes. Now what we want? We want the total surface area here. Okay, so what we want here for this total surface area? So we have to find out 6A square. Okay, and the age of a cube, it is given 1 centimeter. That means age, which is a 1 centimeter. Okay, age of a cube we have, it is a 1 centimeter. Then total surface area, we write 6 times A square. That means 6 times A square means 1 square. Okay, centimeter square. Okay, that means we write 6 centimeter square here. Okay, now see that in our second option we have given correct answer. Okay, the age of a cube, it is a 1 centimeter. Then total surface area for our cube, we write 6 centimeter square. Okay, so that's it here for the answer of our total surface area for our cube. Okay, so I'm expecting that you all have understood this solution. Just need to remember all our solid figures. started from the cylinder, cone, sphere, hemisphere, cube and cuboid. Okay, understand this concept with their volume, total surface area, curved surface area and lateral surface area. Okay, now let's move for the next question. I hope you all have understood now. Yes, now this one is the measurement based question. Okay, measurement based question. Now you all are familiar with the 1 kilogram conversion into the gram. Okay, 1 gram conversion into the kilogram, and another conversion like a meter into kilometer. All these conversion you all are familiar. Okay, so these are easier here, but what about for 1 kiloliter? Okay, what about for 1 kiloliter? We know that 1 kiloliter always we write 1000 milliliter. Okay, this is the measurement based question. You will get at least 2 questions in your SPI question paper. Okay, so you all have to prepare this type of the measurement. So first of all, find out what is mean by millimeter, what is mean by kiloliter, what is mean by decameter or centimeter. All these conversion, find it out first. Okay, and these type of the questions are important for your SPI question. So our required answer we have here 1000 milliliter. Okay, 1000 milliliter. Okay, this one is our required answer. That's it for this question. So just putting this question in my slide, it is the reason behind this. You all have to prepare all these curved surface area, total surface area you all have to prepare all these conversion, milliliter, centimeter, centimeter cube, decameter, all these conversion. You have to understand it here. Okay, that's it for solution for this question. Understand what is the kiloliter, what is the milliliter. Okay, not only for this part, you all have to go for the measurement or measurement of like a square feet, this type of the measurements you have to understand it. Okay, so question based on this you will get in your SPI question paper. Okay, yes, this one is a complete lecture for you all. So as I have added those many questions possible here in my today's lecture. Even after, if you found anything difficult, let me know in my comment section. I will come up with the similar videos. Okay, now what we all need to do now, you have to practice more and more question based on my today's topic. You can find it out the question from your CBSE textbook. Find out some another questions. You can get plenty of the questions from your source of internet. Find it out the question based on the total surface area, curved surface area, after that lateral surface area, volume, parameter, after that circumference, area. Find out this concept on your browser. Okay, check it out, this example, practice it more. It is very much important for mensuration. Without practicing, you cannot expect that to solve these examples. Okay, so I expect you all have understood my today's lecture. So if you found it interesting, let me know in my comment section. This one will be the motivation for me. Okay, so if you want to if you have more interest to learn this concept, let me know in my comment section. I will come up with the separate video based on the mensuration and the trick of these mensurations. Okay, how to remember it for longer. Okay, so I have some of the tricks like that you can remember it for your lifelong. Okay, I'm expecting that you all have understood my today's lecture. So thank you everyone. Thank you for my today's lecture.